So I'm going to do a little summary and discuss some questions, and then after that I'll give you an exercise, and on that exercise you should be able to get all right. Then you know that you know all the basics that have been discussed so far. Alright, let's see. So we'll call this a summary. So the first thing we did was we said that 456 can be rewritten as 400 plus 50 plus 6. Then the next topic that we cleared was that if I gave you A, B, C, then that means A times B times C. In other words, you have to know that you have to put in a multiplication sign. Then we moved on to the next idea, which was terms. And you have to know that terms are separated by plus and minus signs. Therefore, an example would be A plus B, two terms, and minus 5 plus C is also two terms. Here the plus is understood, so it's plus A plus B. Here it is minus 5 plus C. Then we moved on to factors. And we said that factors are separated by multiplication or division signs. For example, 7 times 3, there's two factors. And 5AB really means 5 times A times B. Therefore, there are 3 factors here. Even an example like 8 divided by 2 will give you 2 factors. 8 divided by 2 has 2 factors in it, 8 and 2. Right, then we moved on to powers. And we said an example like 5 cubed, x squared, m to the 10, etc. are powers. Then number 6, we said powers are the same if the base and the index are the same. 6.1 m squared and 5m squared. We are interested in looking at the powers here. Power here is m squared. The bases are the same, m and m. The index here and the index there is the same. So these are same powers. Then we look at another example, m and m squared. In this example, the bases are the same, but the indices are different. The index here is 1, the index here is 2. So these powers are not the same. Then we look at another example. A squared and b squared. Clearly, for equal powers or same powers, the bases must be the same and the indices must be the same. Here the indices are the same, but the bases are not the same. So these powers are not the same. Alright, so here we have an example where the powers are the same because the bases are the same and the indices are the same. In 6.2, the powers are not the same because the indices are different. Although the bases are the same, the indices are different. There are two requirements, so both requirements is not met, therefore the powers are not the same. Now here, again the powers are not the same because this time the indices are the same, but the bases are not the same. And 6.4, A, B, and C, these are also powers, and these powers are not the same. Because in all of these, the indices are the same, but the bases are different. Alright, so I think we're quite clear about what are same powers and where the powers are not the same. So let's come back to these examples. So here the powers were the same because the base and index are equal. So you've got to check two things. The base must be equal and the index must be equal. Here the base is equal, but the index is not. It's not. Therefore, the powers are not the same. In this example, the indices are the same, but the bases are different. Therefore, the powers are not the same. And finally, the indices in this example, the indices are the same. Although the ones were not written, it is understood to be 1, understood to be 1, understood to be 1. So the indices are the same, but the bases are different. Therefore, these powers are not the same. Now, we've got to be very, very clear about this. And at this stage, I just want to remind you that try to learn this bit by bit. Don't try to learn the whole DVD in one go. Try to learn one section at a time. Try to learn about terms, do a little exercise on it. Then learn about factors, do a little exercise on it. So learn them in little bits. Don't try to learn everything at one time. But you are welcome to just sit and relax and view the whole thing at one time. But when you're trying to learn them bit by bit. Alright, let's continue with the summary. Number 7, coefficients. C-O-E-F-F-I-C-I-E-N-T-S. So 7.1, if you take an example like 5m squared, then 5 is called the new numerical coefficient. Numerical coefficient. And the m squared, and the m squared is called the literal coefficient. So, to put it simply, in this term here, there are two parts. The number, and the number is called the numerical coefficient, and the power is called the literal coefficient. But most of the time, we're going to be talking about number and power. These two words, we have to know it, but when we're talking, we're not going to be talking about those two words. We're going to be talking more in terms of power and number, power and number. But you must know this because somebody can ask you, what is the literal coefficient? You'll tell m squared. So let's take another example, 7.25a, or let's make it 15a. 15a. So the numerical coefficient is 15. The literal, the word literal comes from letter. So the literal coefficient is 8. So we must be clear about what is a numerical coefficient and what is a literal coefficient. Alright, so that was a little summary of what we have done so far. And what I'm going to do hereafter now is I'm going to put on a little exercise, and you will have to complete that exercise, and that will be testing to see if you understand whatever has been covered so far. Right, let's move on to the exercise. Alright, so here is a little exercise to test yourself. Another word for test yourself is self-assessment. Number 1, rewrite with signs in between. So you take this number and you must rewrite it with signs. Signs means plus or minus or divide or multiply. Rewrite with signs in between. There's the word fun. Yes, learning maths is fun. Take this and fill in some signs. Number 3. In the following examples, say whether the examples show terms or factors. Alright, so we want to know whether you have terms or factors in each of these examples. 3.1, 2a plus 3b. 3.2, minus m plus 2. 3.3, 5 times a. 3.4, 8 divided by 2. 3.5, fun. 3.6, 2ab plus 3b. 3.7, 2ab times 3b. In number 4, you got to label this power. Put in the label there, and there, and there. Right, number 5, state whether the following powers are the same or not. In other words, after each example, just simply write here whether the powers are the same or the powers are not the same. 5.1, 3x squared and 5x squared. 5.2, 3x squared and minus 5x squared. 5.3, 3x and x squared. 5.4, a and a to the 1. 5.5, a and b. 5.6, x squared plus x plus 3. Number 6, complete the following table by simply writing here what the numerical coefficient is and here what the literal coefficient. In simple words, what is the number, what is the letter. Number 6.1, 5m, 6.2 minus 11 squared, 6.3n. I hope you haven't been cheating. I hope you did these examples on your own and you have now switched on the DVD again to mark your work. Number 1. Alright, number 1, 6, 7, 8. You have to put in signs over here. So you know that this is 600 plus 70 plus 8. Number 2, FUN, fun. Yes, if you're doing English, it is fun. If you're doing maths, it is more fun. So, but this we don't take it as a word fun. It is F times U times N, because we're doing algebra, and in algebra, if I'm given something like this, FUN, then it really means F times U times N. Right, number 3, you had to say whether these were showing terms or factors. So this is showing terms. In fact, it is showing 2 terms. This is showing terms, and in fact it is showing 2 terms. This is separated by a multiplication sign. Therefore, it is showing factors. And 3.4, it's separated by a division sign. So this is showing factors. Now the word, or FUN, well, FUN is really F times U times N, and therefore these are factors. You see, you cannot see any signs over here. Well, you put the signs in yourself and then give the answer. And the next one is clear. 3.6, we are showing U terms. We are separated by plus signs. And 3.7 is separated by a multiplication sign, so it's factors. Number 4, to label, the 3 is the index, or another word for index is exponent. The 5 is the base, and this whole thing is called a power. Alright, we'll move on. Alright, in number 5, you are required to tell me whether the powers are the same or not. Now, from what I have been showing you, you understand what I mean. I mean, don't worry about the numbers. We're only concentrating on these literal powers. In other words, we're only concentrating on these powers. So number 1, it's x and x, and 2 and 2. Bases are the same, indices are the same, therefore the powers are the same. 5.2, 3x squared and minus 5x squared. These numbers don't make a difference. We're interested in these powers here. X squared and x squared, the powers are the same. Now 5.3, you got to be careful. The bases are the same. Never mind if I wrote them a little bit differently. They're both small letter x. The bases are the same. The index there is 2. The index here is understood to be 1. It is not written there, it is understood. So, although the bases are the same, the indices are not the same. Therefore, these powers are not the same. 5.4. The bases are the same. Now we're checking the indices. Well, there's no index here. Well, it is understood to be 1. Now clearly, the bases are the same. The indices are the same. Therefore, these powers are the same. You see, 2 things got to be equal. The bases got to be equal and the indices got to be equal. So you see here, the bases were the same, but the indices were not equal. That's why it's not same. But here the bases are the same, indices are the same, therefore they're the same. Clearly in 5.5 the bases are different, therefore it's not same. Sorry about this little bit of untidy work. Not same. 5.6. Here the bases are the same, but the indices are different. And then here 3 itself is now a base, so it's all different. All 3 are different, therefore we say it's not same. So these powers are not the same. Number 6.1. We want to write down the numerical coefficient. Well, when you look at 5m, the numerical coefficient is 5. The literal coefficient is m. When you look at 6.2, the numerical coefficient is minus 11. You've got to take the sign with it, minus 11. And the literal coefficient is x squared. 6.3. Now be careful. 6.3, there is a number here. The number is not written. It is understood. So in maths, understood means it is there, but it is not written. So we know that the number that is understood here is 1. Therefore, the numerical coefficient is 1. And the literal coefficient is m. Alright, so I hope you did get everything right. If you didn't, don't be disappointed. Just see where you made a mistake, read the section up again, and then retry the whole exercise from start to end, because you must be able to get them right 100% and all the time. So have some fun. I've been using the word understood quite a few times. And we need to know what understood means in maths. Understood. U-N-D-E-R-S-T-O-O-D. What does understood in maths mean? Well, understood means it is there, but it is not written there. So it means that it is there, but it is not written there. For example, number 1, in the number x, there is a 1 in front of it that is understood but is not written there. Now we take the same example again. X, there is an index over here that is understood but it is not written over here. Now if we take the number x, it is understood that x can be rewritten as x over 1. In fact, any number can be written as the number over 1. So here it's x, so x can be written as x over 1. So we've got to be clear about these things that are understood. The number 4, if you take x, there's still one more thing understood here. It is understood that this is plus 1x. Now the plus sign was not written here, and that plus sign is understood. So many things in maths are understood. So I'll just give you another example that's very, very famous. Number 5. Square root of 9. In maths, it is understood that there is a 2 here. The 2 is not written here, but it is understood. So we must know clearly what is understood. Here the number 1 is understood. Here the index 1 is understood. The denominator is understood to be 1. Then there's a plus sign in front. So if I take all this and combine it, then x is really equal to 1, well, it's equal to plus 1x to the 1. You see the plus. I put in the plus there, I put in the 1 there, and I put in the index there. So we must be clear about what is understood. So that's the meaning of understood in maths. Alright, so that ends the story about understood, and I hope it is understood. Back to the basics of algebra. Now we want to do addition and subtraction of terms. Now when you want to add or subtract in algebra, you have to know a little more about terms. So we say terms can be described, terms can be either like or terms can be unlike. So there are basically two types of terms, like terms and unlike terms. Now I'm going to give you some examples. Or firstly, let me explain what are like terms. Now, like terms have the same powers. We do not worry about the numerical coefficient. In other words, we do not worry about the number. We only worry about the powers. The powers must be the same. So, like terms have the same powers. Right, let's take some examples. And now you'll see why we spent so much of time earlier on dealing with powers and explaining that powers are the same. If you take A and B, these powers are totally different. They're not the same. Therefore, A and B are unlike terms. Let's do another example. 3 and A. This is a power 3, the base is 3. This is a power A to the 1, the base is A. The bases are different. So if the bases are different, they are unlike terms. Like terms have the same powers. Now the powers are not the same. So like terms have same powers. Unlike terms have different powers. So if you look here, the powers are different, so it's unlike term. Powers are different, it's unlike term. Right, let's have a look at this one. X squared and 5x squared. Now the powers are exactly the same. We are not worried about the numerical coefficient. You see, the numerical coefficient here is 1. Numerical coefficient here is 5. Now I'm not going to use the word numerical coefficient anymore. I'm just going to talk about number. The number here is 1. The number here is 5. We're not worried about the numbers. We're only worried about the powers. Now the powers are the same. So these are like terms. These are unlike terms. Let's do another example. We are not worried about the numbers. We're only worried about the powers. This power is x squared. This power is x to the 1. The powers are not the same, therefore it is unlike. Let's take another example. 7x squared minus 10x squared minus 30x squared. We're not worried about the numbers. We're only worried about the powers. X squared, x squared, x squared. Therefore these are like terms. So we must be able to differentiate, we must be able to make out the difference between like and unlike terms. Why? Because when you add and subtract, you can only add and subtract like terms. So that is why you first have to know how to differentiate between terms that are like or unlike. Alright, so let's summarize. Like terms have the same powers. If the powers are not the same, then they are unlike terms. Powers not the same, unlike terms. Powers are the same, like terms. We don't have to worry about the numbers. In these two examples, don't worry about the numbers, only worry about the powers. The power here is x squared, the power here is x to the 1. The powers are not the same, therefore they are unlike terms. And why do we say terms? Because, well, I've written the word and here. So you may say, what? Alright, so let's make that clear now. I shouldn't have written the word and, because you'll tell me, so a plus b, 3 minus a plus. So they are terms because they're separated by plus and minus signs. So that's why we call them terms. Terms are separated by plus and minus signs. So all are terms. These are unlike because the powers are different. These are unlike, powers are different. Unlike because, like because powers are the same. Powers are different, so it's unlike. So let's do another example. A plus b minus c. These are terms, but all the powers are different. So this is unlike. Let's do one more. X squared plus x plus y. These powers are all different. Therefore, this is unlike. Alright, I'm going to move over on that side and do a few more examples. The example I'm going to do here, I'm going to show you that there are two groups of like terms in this example. Now, if you watch this example carefully, it's a plus b plus 3a plus 2b. Now, when you look at this example, there are two sets of like terms here. A and 3a are like, and then b plus 2b. So there's set 1. These two are like each other. And these two are like each other. So sometimes you will get an example like this. Then what you can do is we say bring the like terms together. Bring those like terms together. And then you want to add. Well, if you want to add, look, you've got 1a and you've got 3a. If you add it up, you'll get 4a. Then you've got 1b. Remember, it's understood 1b. 1b plus 2b. You add that up, you get plus 3b. And then when you look at this final answer here, these are unlike terms and they cannot be added. You can only add like terms. So here we were finding out what is like and unlike. Here we found an example where we had two sets of terms. The a's are like each other, the b's are like each other. Then if I want to add, I can add these like terms. 1a plus 3a gives me 4a. b plus 2b, this one is understood to be 1b. So it's 1b plus 2b gives me 3b. Then when I look here, I cannot add them up together because these are totally different or they are unlike terms. So you can only add or subtract like terms. Right, we're going to do more examples just now. Let's do another one. So I want to add, or let's say I want to subtract now. So I got 10a minus 5a. Firstly, are the powers the same? Yes. Are the terms like? Yes. Therefore I can subtract 10 minus 5 gives me 5a. So the answer to this example was 5a. So you can add or subtract like terms. But if you look at number 10, 10a minus 5b. Now these are unlike terms. I can't do anything about them. the answer will just remain the same. Or if you wanted, you could have written here, you cannot subtract these because they are unlike. So this is 10a, that's 5b. You can only add like terms, you can only subtract like terms. You cannot subtract unlike terms. And number 11, 5a plus 2b. These are unlike terms because this is a, that's b. The powers are different. I cannot add them up, so it remains the same. So I'm just going to write 5a plus 2b again. It remains the same. So that's why we were learning powers before, because powers is now helping us to differentiate between like and unlike terms. Alright, now what we're going to do is we're going to give you a little exercise where you will have to differentiate like terms and unlike terms. Here's a little exercise for you to do. Classify the following as like and unlike terms. For example, if you are given a plus 3, then your answer will be unlike terms because the powers are different. If you are given an example like a squared plus 5a squared minus a squared, then the powers are all the same, a squared, a squared, a squared. Therefore, the answer is like terms. Alright, so you will have to do this exercise now. Number 1, x plus 3. Number 2, x plus 4x. Number 3, x squared plus x. Number 4, x squared plus x plus 3. Number 5, x minus x. Number 6, x squared plus x squared. Number 7, x squared plus 3x squared. Number 8, x minus 4x squared. Number 9, 2x plus x squared. Number 10, ab plus ba. Number 11, 10ab minus 5ab. Number 12, 11ab minus 5ab squared. Number 13, 5abc plus 4abc squared. Number 14, 5abc squared minus 7abc squared. Number 15, a squared plus 5a squared minus 3a squared minus a squared plus 3. Your solutions to exercise 5. Now, before I write this answer down, I hope you haven't been cheating. So if you haven't finished the exercise, switch off the DVD, go and complete the exercise, and then come back. Alright? So you got caught? You were cheating? Switch it off, go complete the exercise, and then come back to mark it. Good, welcome back. So you've done it. Number 1, x plus 3. You merely have to tell me whether they were like or unlike terms. So this is unlike because the powers are not the same. Number 2, x plus 4x. I don't have to worry about the number. This is 4 and here the number 1 is understood. So x plus 4x, I don't worry about the numbers. Just x and x, the powers are the same. So this is like. Number 3, x squared plus x. If I look at the powers are not the same. This is x squared and this is x to the 1. Powers are not the same, unlike. Number 4, x squared plus x plus 3. Now clearly the powers are all different, so this is unlike. Number 5, x minus x. Well, this is x to the 1, that's x to the 1, the powers are exactly the same, these are like. terms. Number 6. X squared plus x squared. The powers are exactly the same, so these are like. I'm not going to write the word terms all the time. Number 7. X squared plus 3x squared. Now, I don't have to worry about the number. The number here is understood to be 1. The number here is 3. But I don't have to worry about the numbers. I must only worry about the powers. X squared, the powers are the same, so this is like. Number 8. X squared minus 4x squared. Once again, the number 1 is understood. I don't have to worry about the numbers. I must only worry about the powers. X squared and x squared, these are like. Alright, I'm going to move across now onto the other side. Number 9. 2x plus x squared. Now clearly the powers are not the same, so this is unlike. Number 10. AB plus BA. Now, I need to explain something to you here. See, if you're comparing the powers, they're exactly the same. The power here is A, the power there is A. The power here is B, the power there is B. These powers are exactly the same. The order doesn't matter. The order does not matter. So in other words, A and A, B and B, these powers are exactly the same. The order doesn't matter. It doesn't matter if you wrote AB here and you wrote BA there. So these two powers are exactly the same. Therefore this is like. Now remember, the order of the powers doesn't matter. In other words, which comes first and which comes second doesn't matter. Number 11. 10AB minus 5AB. 10AB minus 5AB. Well, the powers are exactly the same. A, B, A, B. So this is like. Number 12. 11AB minus 5AB squared. Now, you got your A, you got your A. But you see, here you have B. And here you have B squared. So the powers are not the same. This is AB and this is AB squared. So the powers are not the same, so this is unlike. Number 13. 5ABC plus 4ABC squared. Now if you study this example carefully, you got ABC and here you got ABC squared. So the powers are not the same. Therefore the answer is unlike. Number 14. 5ABC squared minus 7ABC squared. Now clearly there's ABC squared. ABC squared. Now the powers are exactly the same. So these are like. And finally, number 15, we're looking at this whole thing together. So you got a squared plus 5a squared plus, minus 3a squared minus a squared plus 3. And the question is, are all of these like terms? The answer is no, because all of these are like, but the last one is unlike. So all together will be considered unlike terms because there's a 3 in the end over here. So these are unlike terms. Alright, so we hope you got all right. If you didn't, don't be disappointed. Go back, see what you don't understand. If you don't understand something over here, if you don't understand what are like powers or exactly the same powers, go back and review the section on powers and then come back and answer these questions. Alright, so that brings us to the end of solutions to exercise 5. Alright, now I'm going to give this exercise a special name and call it exercise 5a. I'm just giving it a special name. It's exactly the same exercise that you finished just now. In exercise 5, you told me whether these were like or unlike. Now what you're going to do, you're going to go back to these examples and you're going to add or subtract if possible. You're going to add or subtract if possible. So I'm going to do the first two examples to show you how it's supposed to be done. If you look at number 1, x plus 3. Well, they're unlike terms, therefore they cannot be added, the answer will remain the same. If you take number 2, they are like terms. 1x plus 4x are like terms, therefore you can add them up. 1 plus 4, 5, and you write down the x just one time. And you write down the x just one time. Alright, now your job is to go through this exercise and add them all up, add or subtract if possible. So if you're watching from there, I will just read the questions out to you to make them clear. Number 3, x squared plus x. Number 4, x squared plus x plus 3. Number 5, x minus x. Number 6, x squared plus x squared. Number 7, x squared plus 3x squared. Number 8, 1x squared minus 4x squared. Number 9, 2x plus x squared. Number 10, ab plus ba. Remember, ab and ba are exactly the same. The order does not matter. Number 11, 10ab minus 5ab. Number 12, 11ab minus 5ab squared. Number 13, 5abc plus 4abc squared. 14, 5abc squared minus 7abc squared. 15, a squared plus 5a squared minus 3a squared minus a squared plus 3. Alright, add or subtract if possible, because in some examples it will be not possible because the terms are unlike. Alright, so try these examples and then we will come back to you to mark them. So here are the answers to exercise 5a. X squared plus x, these are unlike terms. You cannot add them up, so you will just rewrite it as the same. Next one, x squared plus x plus 3. These are unlike terms, you cannot add them up, so it will be x squared plus x plus 3. You just rewrite the same thing again. Now, if you look at number 5, you got x minus x. These are like terms. So you got 1x minus 1x. So 1 minus 1 will give you 0, and then you write down the x one time. Well, 0 times x is 0. So the final answer is 0. If you take the next example, x squared, they are like terms. This is 1x squared, that's 1x squared. If we add them up, 1 plus 1, 2. So the final answer is 2x squared. If we take the next example, number 7, x squared, these are like terms. 1 plus 3 is 4, and you write down x squared once. X squared minus 4x squared, like terms. Now watch, 1 minus 4. So you could remember your integers now. 1 minus 4, I have 1, I owe 4, therefore I owe 3 and x squared. Right, we're going to move on to number 9. Alright, number 9, x and x squared, these are unlike terms, so the answer will remain 2x plus x squared. Now here we have 1ab and here we have 1ba. But like we told you before, AB and BA is exactly the same. So, if you add them up, you are adding, in your answer you can either write the final answer as AB or as BA, because they are exactly the same, the order doesn't matter. So 1 plus 1 will give me 2, and I've chosen to write AB. The next example is a subtraction example. So first I check the powers. AB, AB. The powers are the same, these are like terms, therefore I can subtract them. 10 minus 5 is 5, and you write down AB only once. Number 12. 11AB minus 5AB squared. So these are unlike terms, the powers are not the same. So you cannot subtract them, leave the answer just like that. Number 13.